Hi everybody. Today we're going to be looking at is the trigonometry of right triangles. Okay, so first things first, we need a triangle. Triangle. Now, before we get into the actual trigonometry, we need to make sure that we know how to label the vertices or the angles in our triangle as well as the sides correctly. So let's label this triangle. You'll notice we use uppercase letters, so I have capital A, capital B, capital C, to denote the angles in that triangle. We also use lowercase letters to denote sides. You'll notice that side A is directly across from angle A, side B is directly across from angle B, and side C is directly across from angle C. So that's triangles. But this is the trigonometry of right triangles. So what is a right triangle? Well, a triangle is a right triangle when two of the sides are perpendicular. They meet at 90 degrees. So I look at this triangle here, I have side A and side C, they come together at angle B, and they are perpendicular, or 90 degrees. I know this because that little box in the corner represents a 90-degree angle. Before we get to our ratios, we need to understand the different sides of our triangle. The first side that we have is our hypotenuse. Our hypotenuse is the side that's directly across from the 90-degree angle marker. The hypotenuse is also the longest side. The other two sides depend on what we call a reference angle. So a reference angle will be either an angle that you are given or an angle that you want to determine the measure of in the problem. The side directly across from the reference angle is the opposite side. The side that forms the reference angle with the hypotenuse is the adjacent side. Depending on my reference angle, that opposite and adjacent side could switch. Now that we know our sides, we can look at our trigonometric ratios. So there's three ratios that we've worked with, sine, cosine, and tangent. Each is a ratio of two sides. The way we express this is we say sine theta is equal to opposite over hypotenuse. The cosine of theta is equal to the adjacent side over the hypotenuse. And lastly, the tangent of theta is equal to the opposite over adjacent. Okay. The mnemonic that we work with in this case is called SOHCAHTOA, okay? SOHCAHTOA. This helps us remember our three ratios and the two sides of the triangle that are a part of that ratio. The last thing that we want to talk about today is the angle of elevation and the angle of depression. First, the angle of elevation. Here you can see it's measured from a horizontal line. The observer, standing on the horizontal or at the horizontal, looks up to an object. We call this line the sight line. The angle of elevation is the angle between our horizontal and the sight line. The other angle that we have to know is the angle of depression. In this example, the observer is looking down to an object, so our sight line is going down. The angle of depression is the angle, again, between a horizontal line and that sight line. Okay folks, so in this first example we are looking to solve for the unknown variable. Our first step is to look for that right angle marker. Okay, that right angle is going to take us to the hypotenuse. Okay, so I know A, our unknown, is in fact the hypotenuse. We next go to our reference angles, in this case indicated by 73 degrees. We go across to the 50 centimeters, so that's going to be our opposite angle. So now we look at our trig ratios and we think which one includes opposite and hypotenuse. Well, it's going to be sine. Okay, so the sine of theta is equal to opposite over hypotenuse. Once we've chosen our ratio, our next step is to sub in our values. Okay, so the sine theta is our reference angle, so 73 degrees, equals our opposite side, 50, over our hypotenuse, which is given the variable a. Okay. Here we want to isolate a, so we're going to multiply a by on both sides. Okay. On the right side, my a's are going to cancel, leaving me with a times the sine of 73 is going to equal 50. Next, again, to isolate my variable, I'm going to divide both sides by the sine of 73. Okay. Similarly, again, on the left it will cancel, and then it will appear on the right. Okay. Once you see the pattern here in terms of the A and the 73 switching places, you don't really need to show these steps, but it is good to have an understanding of the algebra behind them. Okay. We are going to evaluate sine 73 in our calculator. Make sure your calculator is in degree mode, and we're going to keep at least 4 decimal places. The other thing is we use a dot over the equal sign to show that we're approximating the value. Our last step is to do the division, and again we're going to round that to the nearest tenth, so A is equal to 52.3 centimeters. Okay folks, in our second example we have an angle that we're solving for. Again, same step, we start by finding that 90-degree marker, and that's going to take us to our hypotenuse. We then use our reference angle, so in this case theta, to get the other side, which in this case is going to be our adjacent side. So again, we look to what ratio uses hypotenuse and adjacent, and that's cosine. So cosine of theta is equal to adjacent over hypotenuse. Again, we sub in our values that we know, so the cosine of theta is equal to 15 over 38. Okay. In order to solve for theta, what we do is called the inverse cosine. Okay, so this is found in your calculator using the second function and then the cosine button. Okay. Again, we can keep 15 over 38, and we can do this all at once in our calculator. If your calculator cannot do this all at once, you can divide 15 by 38, and again keep 4 decimal places. When we punch this into your calculator, we get theta equals approximately 66.75, which we round to the nearest degree, so theta equals 67 degrees. Okay folks, in example 2 we're told in triangle RST, angle R is 90 degrees, S is 7.8, and T is 6.9. Okay, so we start by drawing our right triangle. Okay, that right 90 degrees corresponds to angle R. Again, we use capital R for angle, and then lowercase for side. So side S is 7.8, which tells us that angle S is across from that. And same thing with side T is 6.9, so angle T is across from that. To start, we're going to find side R. To do that, we use Pythagorean theorem. Okay? Again, these are right triangles, so Pythagorean theorem is always a valid option for us. So R squared will equal S squared plus T squared. R is our hypotenuse, the longest side. So side S is 7.8, and side T is 6.9. Okay? We'll do both of these in our calculator. So 7.8 squared gives us a value of 60.84, and then 6.9 squared gives us a value of 47.61. We can add those together, and we get R squared equals 108.45. Our last step is to take the square root of that value to find R. Okay. Normally, again, when we evaluate radicals, or square roots anyways, we have a positive and a negative answer. In this case, we reject the negative, and we get approximately 10.4 centimeters. Okay? Again, we don't need a negative value, as we're dealing with a length. Our next step is to pick one of the angles to solve for. So in this case, I'm going to pick angle S. Okay? You can see I have 7.8, which is my opposite side. I also have 6.9, which is my adjacent side. I think what ratio has opposite and adjacent? In this case, it's going to be tangent. Okay? Our general form, tangent theta, is equal to opposite over adjacent. Then I sub in what I know, so the tangent of angle S is going to equal 7.8 over 6.9. So angle S is going to equal the inverse tangent. Again, we use that second function with our tangent of 7.8 over 6.9. Okay, we plug this into our calculator. Again, if you have a calculator that can do it all in one step, great. If not, you can do the division and get our 4 decimal places. Again, when we do this, we get approximately 49 degrees to the nearest degree. Our last step is to find the last angle, angle T. To do that, remember all 3 angles in a triangle have to add to 180 degrees. So I'm going to do 180 minus angle R and minus angle S. Okay, so angle T will equal 180 minus 90 minus 49. Which gives us a value for angle T of 41 degrees. So again, that's our solved triangle. We found every side, every angle. Okay, folks, so in example 3, we're looking to find the length of CD. Okay, here you can see I have a triangle within a triangle. So I have my smaller triangle ABC and my larger right triangle ABD. I'm going to start by looking at triangle ABC. You can see my reference angle is 33 degrees. I'm looking for side A, which is between C and B, and then my other side is 200. This is my opposite and my adjacent side, so I'm going to use the tangent ratio. Okay, so tan of theta, again, is opposite over adjacent. I sub in what I know, so tan of theta, sorry, tan of 33 degrees, sorry, is equal to A over 200. Okay. In order to solve for A, I multiply both sides by 200, so 200 times the tan of 33, and again we punch this into our calculator, and I get a value of approximately 129.9 meters. Now I'm going to look at the larger triangle ABD. Again, I have tangent, given that I'm looking at the opposite and the adjacent side. So in this case, the tan of theta, again, opposite over adjacent. So the tan of 42 degrees is going to equal my variable that I assigned x over 200. So my side x is going to equal 200 times the tangent of 42. Again, we evaluate this in our calculator, and we get a value of approximately 180.1 meters. So my last step to find the length CD, I'm going to find the difference between these two sides. So CD is going to equal x, the entire length, subtract A, the second part of the segment. CD then will equal 180.1 minus 129.9, giving me a value for CD of 50.2 meters. Okay, folks, in example 4, we're going to find the length of UV in the triangle on the right. Now you can see we have two triangles. As a result, I'm going to start on the left triangle because I know two sides there. Whenever we know two things, we can solve for an unknown value. So I'm going to solve for this angle here, which I'm going to label theta. Okay. Again, I have my opposite side, and I also have my hypotenuse, which is across from the 90-degree angle. Okay. I think what ratio has opposite and hypotenuse? That's going to be sine. So the sine of theta, again, is equal to opposite over hypotenuse as our general form. So sine theta will equal 45.2 over 54.8. We use our inverse sine now, again, second function, then sine, to determine our angle. We evaluate this in our calculator, and again we get a value approximately, to the nearest degree, 56. Okay. Now what I can do is I'm going to solve for this angle in here, which I'll label as alpha. Remember, a straight line gives me 180 degrees, so if I do 180 degrees minus 93, and then minus the 56 we just found, I'll be able to find angle alpha. Okay, so angle alpha will equal, in this case, 31 degrees. Okay. I now have angle alpha. I have a measure 63.1, my adjacent side, and my goal is to find the opposite side, in this case, UV. Okay, so what ratio has opposite and adjacent? Well, that's tangent again. So the tangent of theta is going to equal opposite over adjacent, and now we sub in the values that we know. So the tangent of 31 degrees is equal to side length UV over 63.1. Okay, this tells us that UV will equal 63.1 times the tangent of 31. We can evaluate this in our calculator, and again, rounding to the nearest tenth, we get that UV is approximately 37.9 meters. So in example 5, we're told Tanisha is looking out from her window 25 meters above the ground. The angle of elevation to Vanessa, who's at the top level of a nearby mall, is 37 degrees. The angle of depression to Taksha, who is at the base of the mall, is 23 degrees. And we want to find the height of the mall. So whenever we're given a problem like this, first step is to draw a diagram. Okay, it doesn't have to be to scale, but a simple diagram to help us see what's going on and what we need to solve for. Okay? So here's Tanisha in her building. She's approximately 25 meters above the ground. Again, we'll label that point T. Okay. Here we have the nearby mall. We know it's going to be a taller building because she's looking up to somebody. Okay. Again, we have the angle of elevation, angle of depression is from the horizontal. So we draw a horizontal line from Tanisha's location, an angle of elevation to the top of the mall. So the angle of elevation is 37 degrees above the horizontal. Okay, and this is to our friend Vanessa, point V. Okay. We're also told that she has an angle of depression 23 degrees to Taksha, and we'll denote that with an A. Okay, so I know that Tanisha is 25 meters above the ground. What that tells me is that the side of the lower triangle is also going to be 25 meters. Okay, so I'm going to label this side 25 meters. Now, given I have an angle, I have the side across from it, which is going to be my opposite, and I'm looking for this side here, which I'm going to label as A. Okay, so I have my adjacent side and my opposite side, so I'm going to use tangent to find out the distance between the two buildings. Okay, the reason I want to do that is because that's my shared side between the two triangles. So the tangent of 23 is going to equal 25 over side A. Okay, we rearrange and get A. A is equal to 25 over the tangent of 23. Again, we can solve this in our calculator. We get A is approximately 58.9 meters. Okay. Now I'm going to go to my top triangle. So I have a reference angle of 37. I know side A, my adjacent side. I'm going to use T to measure or to represent the other side. Again, I have opposite and adjacent, so again I'm going to use tangent. Okay. Okay, so in this case, the tangent of 37 is going to equal my opposite side, T, over my adjacent side, 58.9. Okay. To isolate for T, we multiply both sides by 58.9. So T will equal 58.9 times tangent of 37. We punch all of this into our calculator, and we get a value for T of approximately 44.4 meters. Okay. This doesn't represent the height, though. This only represents side T. So what I have to do is, to get the total height, I have to add T and 25. Okay? So H is going to equal 44.4 plus 25, giving me a total height of 69.4 meters. In example 6, we're told that Aisha and Ali are standing on opposite sides of a tree. The angle of elevation to the top of the tree from Aisha is 30 degrees, and from Ali is 35 degrees. If they are 65 meters apart from each other, how tall is the tree? So the first thing that I recognize here is I just have two people standing on opposite sides of a tree. Okay, they both have A names, so I'm going to represent the first person, Aisha, as Y, and then the second person, Ali, as L. Okay, I know that the distance between them is 65 meters. Okay, I know somewhere on this line there's a tree. Okay, the angle of elevation from Aisha's perspective is 30 degrees. The angle of elevation from Ali's perspective is 35 degrees. Okay. What I'm looking to solve for is the height of the tree, which I'm going to label as h. Okay. So I only have one thing unknown in each triangle. What I'm going to do is I'm going to use x to represent this side here. Okay, I don't know how long x is. What that tells me though is this length in this triangle is going to be 65 minus x. Okay, because the total difference is 65, and if the left chunk is x, subtraction gives me that value. So based on the first triangle, my reference angle of 30, I have the opposite side and the adjacent. I'm going to use tangent. So tan of 30 degrees equals h over x. Okay. I'm going to rearrange this to get x isolated, so x equals h over tan 30. I'm now going to look at the triangle on the right half. Okay, from my reference angle, I have opposite and adjacent, so again I'll use tan for this one as well. So the tangent of 35 degrees is equal to h over 65 minus x. I'm going to switch the location of tan 35 at 65 minus x. So I have 65 minus x equals h over the tangent of 35. Now, if you're looking closely, what we actually have here is a system of equations. I have two equations, two unknowns. So I'm going to use substitution and sub x equals h over tan 30 into the equation I'm working with. Okay, so h over the tangent of 35 equals 65 minus h over tan 30. Okay, now it just becomes a slightly drawn out algebraic process in terms of solving for h. Okay, my first step is I'm going to collect the terms with h on both sides of the equal sign. So I'm going to add h over tan 30 to bring it over there. Okay, I need a common denominator to add these two fractions together. So my common denominator in this case is tan 35, tan 30. So I have to multiply my first h by tan 30 and my second h by the tan of 35. Okay, and again that's over my common denominator of tan 35 times tan 30. Okay, and again this will equal 65 degrees. Or sorry, 65, not degrees. Okay. My next step, I'm going to factor h out of the numerator. Okay, so that's going to be tan 30 plus tan of 35 in brackets. Okay. I'm also going to multiply on the other side by tan 35 times tan 30. Okay, so I'm going to eliminate my fraction that way. Okay, my last step here, I divide both sides by what's inside the brackets on the left. So tan 30 plus tan 35, giving me h equals 65 times tan 35 times the tan of 30. All of this over the tan of 30 plus the tan of 35. From this point, again, we can use our calculator to solve, and we get a value approximately of 20.6 meters. Okay, folks, example 7. We're told that Chester and Nemo are both on the same side of the cliff. Sighting along the same line, Chester views the top of the cliff at an angle of elevation of 21 degrees, and Nemo, who's in front of Chester, views the top at an angle of elevation of 29 degrees. If Chester is 30 meters from Nemo, how tall is the cliff? Okay. So again, we start with a quick diagram. I have two people, so I have Chester here. I'm going to use that as C. Nemo's in front of him, N. And then somewhere over here, I have a cliff. Okay, I do my horizontal to be able to show my angle of elevation. I know the distance between C and N is 30 meters. Okay. Again, the angle of elevation from Chester's point of view is 21 degrees, and from Nemo is 29 degrees. What I'm looking for is the height of the cliff there. Okay, so I'm going to start by looking at that first triangle inside. I'm going to use the x to represent that side. So I have my opposite and my adjacent side. So I'm going to use tangent again to solve this problem. So the tangent of 29 is going to equal h over x. Okay, again, I rearranged to isolate for x. So x equals tan of 29, sorry, h over the tangent of 29. I now look at my larger triangle. 21 is my reference angle. The side adjacent to it is going to be 30 plus x. I'm going to add those two measures together. Okay, and then again I have my opposite side h. So again I'll use tangent. Give me the tangent of 21 degrees equals h over 30 plus x. Okay, very similar to the last question in that we have a system of equations, which again I am going to solve using substitution. Okay, I start by getting x out of the denominator, and now I can sub in my value into my second equation. Okay, so h over tan of 21 equals 30 plus, and then the value for x that I found in my first equation, h over tangent of 29. Okay, we collect our like terms. Okay, so I get both my terms with h's on the left side of the equal sign by subtracting them, and that'll equal 30. Again, I need a common denominator to add those fractions together. So my common denominator is tan of 21 times tan 29. So I multiply my first h by 29, sorry, the tan of 29, and my second h by the tan of 21, and all of that is over tan 21 times the tangent of 29. Okay, and then this will equal 30. Okay, my next step, I'm going to factor h out of the numerator, leaving me with h times the tangent of 29 minus the tangent of 21. And then I'm going to multiply 30 by the tangent of 21 and the tangent of 29 to eliminate my fraction. My last step here to isolate h is I divide both sides by the tangent of 29 minus the tangent of 21, giving me a value of h equals 30 times the tangent of 21 times the tangent of 29 divided by the tangent of 29 minus the tangent of 21. Okay, we punch all this into our calculator and we get a value for h of approximately 6.8 meters.